Big thanks to Craig from AC Service Tech and acservicetech.com for coming down and shooting this series of videos with us. This video specifically is about flaring and swedging, but if you want to learn more about the entire range of processes and procedures for our industry, go to acservicetech.com or subscribe to his YouTube channel at AC Service Tech. Hope you enjoy this video. Swedging and flaring. That's what we're going to talk about.
Is it swaging or swedging?
Oh, swaging. Oh, there we go. Okay, swaging and flaring.
I don't know.
Or is it because now they're calling it expanding now, tubing expanders. They don't even say swage.
Yes, right. There's a lot of the tools that are expanding tools. So, you can call it whatever you want. And I have the same problem with OL on the multimeter. Every single time I designate OL, meaning something when I'm testing resistance, open loop. No, it's open line. It's open line. No, it's over the limit of resistance in which is in the circuit. It doesn't matter.
Yeah.
No matter what you say, it's going to be something else instead. But hey, it all works.
So, which do you say? Do you say swage or swedge?
I say swage.
Swage.
Okay. I think I started saying swedge, and everybody kept busting my chops so much about it and it was one of those YouTube growth things where I think and not to say that was the correct decision on that one, but I now call it swage because of so many people who said, I grew up calling it swage and that's how you're supposed to say it and da-da-da. I'm like, fine.
It's swage. I say swedge, so.
Hey, well, that helps me then.
It makes you feel better about
confident.
your early content.
That's right.
Good.
That's good.
That's what I'm here for. I'll be your emotional support animal from now on. Let's start with flaring. Let's just go right to because people sometimes get frustrated when you talk around a thing. We'll start with your favorite and my favorite flaring method, and then we'll go into why and some of the options. So it's just personal. So caveat: this is personal preference, right? When we do this, and I'm okay. I'm okay with you mentioning a brand if you want. If you don't want because of your channel, that's fine. But I'm going to mention brands. I'm just going to say it. So you go first. What is your favorite method for flaring currently?
Well, let's just get this out of the way. A lot of it, Yellow Jacket, Uniweld. That's fine. But I usually use a round reamer. And I often get this question, how do you ream or deburr? Sorry, because that's the other thing. That's the other thing you get corrected on a lot.
You get reamed about that if you say the wrong thing.
Yep. So you're deburring a copper tube, and you want to do that with the opening upside down. And I get asked, well, how do you deburr a tube that's upright and is fixed? Well, a lot of times the tubes that you're flaring are smaller, so you can bend them downwards and then bend them back up. Make sure that you're not bending near a braze joint that you're accidentally going to crack. But when it's upright, you don't really have that much of an option. You kind of have to just use the flaring tool and flare it out without deburring it and try to make it as large as possible. I don't know. Do you have any wisdom there?
Yeah, well, a lot of people will make goofy. They'll say like, well, you can take some electrical tape and you can roll it up and you can stick it. No, I don't want you doing that.
Right.
Again, there's different levels of technicians. There are technicians who have done things like rolling up a piece of something and put it in there for years and years, and they're good at it and they know what they're doing. Fine. But don't tell me about it, because all I can think of is my 3-year technician who's going to drop something in the line and leave it in there. In terms of flaring, deburring is pretty important. It is pretty important.
Absolutely.
It makes a better flare. But depending on the tool you're using, there are tools that are more forgiving, in terms of burr. And then there are tools, and this is actually something that I would be very careful with. There are tools that will deburr in the process of using them, and that burr can still go into the pipe.
Absolutely.
So I would be careful with that. And again, we're going to keep saying the same thing, know your tools, and if you know your tools and you know how to use them properly, then you'll do fine probably. But I mean, I like most people, started off flaring with the basic, imperial block, the old school block where you take the handle and you're using it to tighten and untighten and all that stuff. It worked fine as long as you did it right. But to the question and the table here, it's important, but what's more important is not getting copper shavings in the line. If you only have two options, then I would say don't deburr in order to not get copper shavings in the line. That's my stance on it.
Okay.
That was a really long answer.
No, I'm glad you said it. It just kind of, makes me feel better, but that's what I tell everybody. So in reference to the tools that I usually use a round reamer or a round deburring tool, anytime that I am deburring, getting ready for flaring. And the reason for that is I personally I don't use a stick deburring tool. I know you like to use that in a classroom. A lot of times what I've seen is, at least if you're not comfortable with using it,
Right.
and if you're not using it all the time, what tends to happen is you end up accidentally scraping the inside surface of where you're going to flare at.
Right.
And then you go and put that copper tube in the flare block, you flare it, and you end up with still some type of a scratch surface of,
Right.
or some sort. So you just got to, whatever deburring tool that you use, you got to be familiar with it. And it should have a good angle on it, but not touch the insides of the copper tube. And then I like the eccentric flaring tools. I like the ones that don't have a guide stop, although a guide stop makes it easy and quick and fast for making multiple swages. But I like to be able to manually put my copper tube in a block, and I like the eccentric flaring tools where it's only applying the force on the copper tube in one spot at a time. It's not the entire cone pressed up against the copper tube with friction, and so it makes the least amount of surface contact with the copper tube, and that tends to make what I feel is the best copper tube flare. Of course, you put a little bit of refrigerant oil to help it glide, and a little bit of protection, and you hit the point earlier where hey, maybe you can't deburr, but then you have your copper tube actually may, depending on the head that's on the tool that you're using, might cut into that head a little bit. It just depends on what tool you're using. But I like eccentric flaring tools, round reaming tool.
Round reaming tool. I just haven't practiced enough with them. It's an example where when I started in the trade, I always had the little, it's just one of those things. It's like, it's the tool you grew up using or started off using, and you get used to using it. And to your point, they have the blade deburring tool has that rounded tip that's supposed to go in there and rub up against so it doesn't cut into it. But I see it all the time, either damaging the inside surface or over reaming, where you thin out the edge and now it splits on the edge after it's done flaring, which ultimately comes down to like, and I'm again jumping way ahead here, but at the end, when you're done with the flare, check it and make sure it's a good flare.
Right.
Like it's not that complicated. It should be round. It should have a very smooth surface on the inside. It shouldn't be cracked around the edges, and it should be large enough that it covers the entire flare. And it should fit snugly into your flare knot. And also remember to put the flare knot on first. So that's a big one.
Yes.
My favorite currently, and this is a cheat, and I know I'm going to get it from everybody, but the new Hvac battery-powered NTE11 or whatever it is, and it's not the NTE11. I don't remember what it is. I like it, not necessarily for myself because I don't need it, but it does it so quickly. I mean, it's just makes the flare, back it off, and they really are pretty darn good quality flares. And for our techs in the field who are doing a lot of ductless systems, because we do a lot of ductless, it just takes the guesswork out of it, and it's what I hand the technicians. And a lot of people will think when I say these things like, oh, well, they're a sponsor, so you were paid to say that. No, I just used it and I really like it. The NEFLI, which was the previous version, was also great. It's just a little bit more pricey. So that's my favorite currently. As you know, I use the blade tool, but really, you can make a good flare with almost any available tool. I mean, the old Imperials, because when I talk about the process, people will always push back. Well, look, we've made good flares for years. We didn't need all this. Well, there are a couple factors. One of the factors is with higher pressure systems, the flare does become a little bit more critical. But I wanted you to talk a little bit about, because you had mentioned this, about getting sort of the maximum, because you said you don't like the stop. And I actually tend to agree. I would probably make them a little bit larger than some manufacturers would specify. But why is that? Talk through that a little bit.
You had hit it on the head when you were talking about the deburring or the reaming at the end of the copper tube. And if you do that too much, you're going to basically ruin that amount of surface area on the flare. If you make the flare big enough and to where it just barely fits in the flare nut, and by the way, make sure you're always using the manufacturer's flare nut, not the ones that are maybe cheap and smaller one that comes with the line set. Yeah, because I've seen a lot crack out there in the field, and that's a problem. I like the flares that are so big to where you're actually almost screwing the flare nut over top of the flare, and not hard screwing, but like by the time it gets down into the area of the flare nut where it's supposed to be resting, it swivels freely. The nut swivels just freely, and you have the maximum amount of surface contact with the flare face on the adapter. A flare, you don't want to have the flare the exact size as the adapter, because a lot of times the part where you're deburring is on an angle and you're really not using the maximum amount of surface on the flare. I mean, that is a huge thing. I even see it coming from manufacturers with TXVs or whatever these tiny little flares.
Yeah.
It doesn't even fit over the flare adapter. Right. What's going on here? You're only using half of the surface area. It doesn't make any sense. For these higher pressure systems, you want to make sure, to visually inspect your flare and make it a little bit bigger. You don't have to thread the flare nut on.
Right.
But take the entire area within the flare nut to your advantage.
Key thing that you mentioned there is that, look at the size of the flare compared to the flare adapter, compared to the male part of the flare. Do they butt up against each other completely? Does it cover completely? If it doesn't, then you're not using, you're not getting the full advantage, right?
Yeah.
A lot of people will focus a lot on the degree of angle of the flare. What are your thoughts on that?
Well, there's some tools that make a, say, incorrect angle on purpose, and then when you tighten it in, it then tightens it to the exact angle in which it's needed. The reality is, if you get it close with your 45-degree flare, it's going to mesh up to that flare face no matter what. It's copper,
right?
And so I tend to use a little bit of Refrigeration Technologies Nylog on the flare face. And I've had a lot of people say, well, you put it on the threads. And I say no, because then you're making that slick and you're going to accidentally over tighten the flare.
Torque spec,
but I put a little bit just right on the flare face, not enough to where it's going to get inside the tubing,
right?
But just on the flare face itself. And but yeah, it's just the surface area. You want to make sure that it makes nice contact and a 45-degree flaring tool. I mean, that's what we use, and it'll form fit right onto that flare face.
Yeah, either way. So, for example, the spin flare tool, they talk about how they, under make it a little lower degree, and it does work fine. It's right. It's not a problem either way. I think it's one of those things that maybe some reps got their hands on and used it as a selling point, right. And I really think it's kind of a non-issue. But people will say that. They'll say, oh, well, your old flaring tool won't work with the newer flares. It's like, that's funny because I've done it plenty. The one thing that does tend to be the problem would be just the face area, the size of the flare matters more than it used to, because it is a press fit fitting. It's not and this is a mistake a lot of people make, because I'll be honest, we use Nylog on a lot of threaded fittings, and you're right, it does affect the torque spec, but it's not the threads that hold. Right. That's the key thing here. It's not the threads that hold. If it's a chat lift or an air equip fitting, it's some sort of a seal. If it's a flare fitting, then it's just literally press fit.
Exactly.
It's all about getting maximum surface area, appropriate force pressure face to face, and having as few inclusions or gaps, cracks, anything in that face as you can possibly have. And that's it. It's really not any more complicated than that.
Absolutely. And I think across the United States, what I hear a lot of times, and of course it's the whole world, is that people sometimes really don't like mini split systems because it has flare fittings. And of course there's ways to get around that, and you can flow nitrogen and breeze depending on the manufacturer, but it all has to do with the flare fittings and the technician being able to make a good flare fitting, and you hit it on the head in reference to the higher pressures that we're using now. It's not just on the low side of the system, it's now on a heat pump. And I just said, during the middle of my sentence. You didn't call me out.
I know. I wasn't paying attention. I was busy thinking about lunch. So
yeah. But you have to make that flare as good as possible. And it's just like anything else. Once you say master a subject or a process, it may take you longer in the beginning, but once you get it down, you can do that real rapidly, and everybody has confidence in you doing that job. And that's what's most important about everything that we do in the HVACR field.
In this case, it don't leak. At the end of the day, you win if it doesn't leak.
Yes.
Now and later, both. It shouldn't leak. All right, so let's talk about swaging, swedging, or tube expanding, whichever you prefer. Let's go straight to, again, the conclusion. What is your preferred process?
So I will tell you, I'll back up a little bit, because when I started out, I just used the hammer swages. That's what everybody used in the company in which I started with. I mean, there's a lot of different methods. I prefer having something that's going to take up the entire area inside the swage. I don't absolutely 100% love the expansion tools that leave a little kind of gap. They spread open. Mm-hmm. They work, and that's great, and certainly they work for the larger tube. But then, people say, oh, well, you should heat it up beforehand. But then if you heat it up, are you creating a problem with oxidation inside the tubing prior to even hooking this thing up? But you can use an expanding tool on a room temperature piece of copper tube. But there's also tools out there that spin, like you said, the spin swage, and that you can put right in there. or a drill swage, and you're putting that into the copper tube, and you're causing it to friction and heat, and you're expanding the copper tube as well. You're cleaning the inside of the copper tube. So I like that for some applications. You got to make sure that that tube is faced downwards. If you have an upwards facing tube, I'm not going to use a drill swage because of the dust needs to fall out of the tube. You may not notice it, but there is going to be some dust, and I don't want that to fall inside the tube. In the classroom, I've taught a bunch of different methods: the expanding heads, the hammer swages, the old school just standard block, and you're just tightening it right in. I don't know if I have a favorite. I will be honest with that, and that's why I've done some videos where I'm not saying it's my favorite. I'm just showing you, hey, this is how you use each of these tools.
Correct. Yeah.
So I don't think I have a favorite. I don't think.
Yeah, and I think you've hit on some really good points in terms of using an expanding tool. The key thing is that you have to release and turn it as you go. Like you can't just expand it one time. I mean, in most cases you're going to split it and it's going to be quite obvious, but even if you don't split it, you're weakening it. I do not suggest using a tubing expander anywhere near the compressor, especially on the discharge line. Yeah. On a suction line that's away from the compressor where there's less vibration. An example would be in real life, a lot of times you'll go to a system and your suction line at the condenser and air handler don't match, and you have to kind of like make them fit. And so sometimes you use a different piece of copper, but even then it won't fit. Exactly right. And so sometimes if you take a tube expander and you just expand it just a little bit in order to make that fit tighter, that's a good application for it. And then sometimes it's just a matter of, you're trying to reduce fittings, and so you're going to expand on a suction line or even on a liquid line where there's not as much vibration. But if we were in, say, a grocery environment, a more mission critical, higher charge environment, definitely wouldn't use an expander that's going to potentially weaken the joint. And then from there, what are your options? I think the spin swage is a really nice tool. I think it works great. Again, you pointed out that you got to prevent any shards of copper, whether they're tiny, they're big or small, from getting into that line. I will add that if you ever do know that you drop something in the line and you can't recover it, I think that is a good application for pipe wiper, to run that pig through and blow it out again if you find yourself in that position, but not a good position to be in. So try to prevent that. And then, like you said, you got the old school hammer swedge or the block swedge. When you get into those zones, a lot of times you may be just as easy to use a fitting, But, so there are cases where a fitting is the right choice. For example, if you are working very near a compressor in a discharge line, I would not suggest probably swedging in that application, because again, you are taking one size and you are making it bigger. You are thinning it out. So I think just knowing your situation probably dictates the best process there.
Yeah, there's a lot of times where I have just used fittings, and the objective of having your swaging tools is to make a swage quickly without absolutely needing to have a coupling or a reducing coupling, and you're reducing the amount of joints in which you need to braze, so it's less chance for leaks. But once you get good at brazing, usually that's not where the problem ends up being. Right. It's somewhere else. And you tend to put more braze on than probably what's needed, necessary, even though you're trying to get in and out. This way you're not beholden to having the exact coupling that you need on the service truck. So you really want to have a bunch of your swaging tools for different applications. And so from old school to new school, you want to have something in there in your truck to rely on.
I think that's it. Remind people how they can find out more about you and what you got going on, your books, your website, all that stuff.
Yeah, so we're always making new videos on YouTube at youtube.com/AC Service Tech channel. And we have a bunch of articles and quick tips and calculators, quizzes, and also our book over at our website at acservicetech.com. And then you also have our air conditioning book, which is the refrigerant charging and service procedures for air conditioning. And it's always so long, you have a hard time saying it.
It is. You started slurring it.
Always. Multiple takes. But anyway, we have the full outline there at acservicetech.com/AC book. So you can check out, if you're asking or wondering what is in there, just look at the full outline. It's right there. And we have some sample pages there as well. We have a 1,000-question workbook. We've got quick reference cards. We've got posters. And I'd love to see these things used in technical schools across the country and other countries. We have posters on mini splits. We've also got PowerPoints that teachers can use. We have a bunch of resources there, and we also have our physical products over at Amazon as well. We have our ebook on our website and Google Play and iTunes.
Nice. It's a lot of stuff.
Yeah.
You almost have as much stuff going on as I do.
I don't think as much, maybe. I don't know.
I've just got you beat on kids, so that's kid
That
number.
is true. That is true.
That is where
That's a true
that is
miracle.
where I win. Yeah. All right, thank you, man.
Thanks for watching our video. If you enjoyed it and got something out of it, if you wouldn't mind hitting the thumbs up button to like the video, subscribe to the channel, and click the notifications bell to be notified when new videos come out. HVAC School is far more than a YouTube channel. You can find out more by going to hvacrschool.com, which is our website and hub for all of our content, including tech tips, videos, podcasts, and so much more. You can also subscribe to the podcast on any podcast app of your choosing. You can also join our Facebook group if you want to weigh in on the conversation yourself. Thanks again for watching.